Then in today we are going to use the matrices to solve system of linear equations. And we have two types of the linear equation. One which is called non-homogeneous equations, and the other one which is called homogeneous equation. To differentiate between them in the non-homogeneous equation, in the right side of the equation itself, you will find some values. Where in the case of the homogeneous equation, you will find on the right side all the time zeros. Anyway, to solve the non-homogeneous equation, we have many methods or many ways. The first one here, which it will be the inverse matrix method. And we have also the Gaussian elimination method, which you can rename it also echelon matrix method. We have another method which is called the Gaussian-Jordan method or elimination method, or by another way you can rename it reduced echelon method. And also we will use the rank to discuss the different solutions of the non-homogeneous equations. And we will use the Gauss elimination method or Gauss-Jordan method or even the ranks also to discuss the solution of the homogeneous equation. Here in this example, I will use the method of the inverse matrix to solve this system of equation. And as you can see, hence I have values here, that means this is non-homogeneous system. Anyway, first of all, I will try to insert those equations in the matrix form. First, I will try to insert the coefficient of x. In front of x, I have 3, and in front of x here I have 1. Then the first column here, 3 and 1. The coefficient of y, in front of y, I have 2, and down in front of y, I have 4. Then here I have 4. Inside those equations, I have two unknown. One of them x, and the other one which is y. Then here I'm going to write x and y. On the right side here, the three numbers which I have, -2 and 6, then I will put them here, -2 and 6. Anyway, the first matrix here, we used to rename it the coefficient matrix. The concept of the solution here, it's very easy. I will rename the first matrix, this one, as suppose A capital. And the second matrix, which is the matrix of the unknowns, you can rename it suppose X capital. And all of that equals to this matrix of the right side, you can rename it the matrix P. Then from this matrix equation, I would like to obtain the matrix X alone, the matrix of the variables alone. Then to do that, I should remove A from here. To remove the matrix A from that place, I will multiply this equation, the both sides, left and right, by the inverse of the matrix A. Then let's do that. I will multiply the left side by the matrix A. Then this is multiplied by the matrix A multiplied by the matrix X. And also on the right side, I will multiply also by the inverse of the matrix A. Then it will be A inverse multiplied by B. Now, if you remember, when you multiply the inverse matrix by the matrix itself, they both together, they will give you what? They will give you the identity matrix I. The identity matrix I, it will be multiplied by the matrix of unknown X. And all of that equals to A inverse multiplied by B. As you saw before, when you multiply the identity matrix by any matrix, the answer will be what? The answer will be the matrix itself. Because we said that before, the identity matrix, it's look like 1. Then when you multiply the 1 by the matrix, it will give us the matrix itself. Then this matrix equal to the inverse matrix A multiplied by B. Then here is the rule of the solution. This is the rule which we are going to use to solve this system. Then now I will use this rule to solve this system. As I told you before, you should convert this system into the matrix form. The coefficient of x 3 and 1 and the coefficient of y 2 and 4. And here the unknowns x and y and the free number here -2 and 6. Then let's now use this rule. Then I will substitute directly inside the rule itself. Then instead of this matrix, I will put the unknowns which I have. I have here x and y. And here I have the inverse matrix of A. This is the matrix of A, which is 3, 1, and 2, and 4. And instead of B, I will put the matrix B, which is this, -2 and what? And 6. Then to obtain the answer here, I should compute the inverse of this matrix first. After that, I will multiply it by the second matrix. Correct. Then we can do it right now. I have here x and y, those the unknowns, equals to the inverse of the first matrix, but multiplied by -2 and 6. Then first, let's compute the inverse here to be easy for us. Then I will try now to compute the inverse of this matrix. 3, 1, 2, and 4, which is called the matrix A. As you remember, to compute the inverse, I should obtain the determinant first. Then I will open two brackets between them, subtraction. Multiply 3 by 4, which is 12, minus 1 multiplied by 2, which is 2, then 12 minus 2, the determinant will be how much? Will be 10. After that, I should compute the A adjoint, which is very easy, the adjoint here for the case 2 by 2. What I will do, I will swap between those two numbers. I will change their places, then 4 it will come up and 3 down. And I will change the sign of the remain, then the 2 it will become -2, and then here it will become -1. Then to compute the inverse equals to what? Yes, 1 by the determinant of A multiplied by whom? By A adjoint. Then I can say what? The solution here, x and y equals to, instead of this matrix, I will put this rule, 1 over determinant A multiplied by A adjoint, and all of that multiplied by -2 and 6. Then right now I will just substitute. Then here the variable x and y, 1 by the determinant equals to 10, and the adjoint, we did it before, it was 4, -1, and -2, and then 3, and remain with me -2 and then 6. Then to continue, I will just make multiplication. Then I will keep 1 by 10, and I will try now to multiply this matrix by the second one. Then to do that, as we used to do, I will start to take the first column, the first row from the first matrix, and I will multiply it by the column, and the answer here it will be row. Now let's multiply the first number with the first number, 4 multiplied by -2, -8, and multiply the second number by the second number, it will give us -12. Then this is finished. Now I will remove the first row and I will try to deal with the second row. Then I will take this row and I will multiply it by that column. It will produce here another row. Let's start. -1 multiplied by -2, which it will become +2. And 3 multiplied by 6, which it will become 18. Now try to simplify your answer. Then xy equals to 1 by 10. And here I have -8 and -12, which is -20. And the 2 plus 18, which is 20. +20. Now you can multiply 1 by 10 inside. Then xy, those is the variables, equal to -20 divided by 10 and 20 itself divided by 10. Then now the answer finished. The first variable x equal to the first number here. Then I can say x equal -20 by 10, which is -2. And the second number equal to the second value. Then y equals to +20 divided by 10, which is 2. Then I have here the value of x and I have here the value of y. Now let's solve another example. Then I will use the inverse matrix to solve this system of equation. Then first of all, I will try to insert this system in the matrix form. Then I will make one matrix for the coefficient and one matrix for the variables equals to one matrix for the right side. The coefficient of x in front of x up and down, I have what and what? I have 3 and 1. The coefficient of y, what and what? I have 5 and negative 2. How many variables inside those equations? Yes, I have variable x and the variable y. The free numbers which is lays on the right side, negative 1 and then 4. After that, I will write the rule of the solution. What is the rule? The matrix big X or capital X, this is the matrix of the variables, equals to A inverse multiplied by B. Then let's substitute. The matrix of the variables here, it's mean X and Y. Then this is the matrix of the variables, X and Y, equals to the inverse matrix of the coefficient. That's mean this coefficient. Then here I'm going to put 3, 1, and 5, and negative 2. And B itself, then this is the A inverse, I mean. B itself, it's mean the right side matrix, which is negative 1 and then 4. Then you can say now the variables X and Y equals to, as you can see here, this is the inverse matrix. Then I can replace it by what? By 1 by the determinant A multiplied by A adjoint. And this matrix, it will be remain with us, then I should drop it down. Then all of that multiplied by negative 1 and then 4. Then to complete the answer, I should compute determinant A and I should complete A adjoint. After that, I will make just multiplication. Then let's do that here. The matrix A itself, it was what? 3, 1, 5, and negative 2. Then let's compute the determinant of that matrix. How that? I will multiply 3 by negative 2, which is negative 6, minus, multiply now 5 with 1, which is just 5. Then the determinant here equal what? Negative 6, negative 5, which is negative 11. After that, I will compute the A adjoint. A adjoint equals to, I will swap between the diagonal items. The negative 2, it will go up and 3 down. And then we will change the sign of the remain. The 5, it will become negative 5. And the 1, it will become negative 1. Then now I will substitute about A adjoint there and about the determinant there. Then the matrix of the variables X and Y equals to 1 pi determinant A, which is negative 11, A adjoint negative 2 and negative 1, and negative 5 and then 3. All of that multiplied by negative 1 and then 4. Then the variable matrix X and Y equal 1 by negative 11. And now let's do the multiplication between the two matrices. Then I will multiply the first row by the column and the answer, it will be row. Let's make the multiplication. The first number with the first number, negative 1 multiplied by negative 2, which is positive 2. And then negative 5 multiplied by 4, this is negative 20. Now we have finished the multiplication of the first row. Let's move to the second row. Then let's multiply the second row by the column. It will give us here new row. The first number with the first number, negative 1, it will become positive 1. And 3 with 4, which it will become what? It will become 12. Now let's simplify the answer. Then the matrix of the variable X and Y equal 1 by negative 11 multiplied by 2 minus 20, which is negative 18. And down here 1 plus 12, which is what? 13. Now we will multiply this number 1 time by the first number and 1 time by the second number. Then the variables X and Y equals to negative 18 by negative 11 and 13 by negative 11. Then now the first number equal to the first number and the second number equal to the second number. Then X equals to negative 18 by negative 11. You can cancel the negative with the negative. It will become 18 by 11. And now the second number with the second number, then Y equal 13 by negative 11. Then here is the solution. This is the value of Y and this is the value of X. Then now let's use the inverse matrix method to solve the system of the non-homogeneous equation in 3 unknowns. Then as usual, first of all, I will try to put those inside the matrix form. Then the coefficient of X in front of X, I have 1 and I have 3 and I have 2. Then it will be here the first column 1, 3 and 2. In the second column coefficient Y, I have 2 and negative 2 and here I have positive 1. Then I will put here 2 and negative 2, and then I have positive 1. In the coefficient of z, I have 2, and I have here 1, and I have here negative 1. Then 2 and 1 and negative 1. The variables here, I have variable x and variable y and variable z. Then here I have variable x and y and z. The free number, which is in the right side, I have here 5 and negative 6 and negative 1. Then here 5, negative 6 and negative 1. Then here the rule of the solution. Then x refer to what? The matrix of the variables. It's mean this matrix. Then here I will put x and y and z. No issue for that. Okay. After that, how to compute A inverse? It's easy. 1 by determinant A multiplied by A adjoint, multiplied by the matrix B. The matrix B here, the matrix of the right side, which is this. 5 and negative 6 and then negative 1. Then to complete the solution now, I should obtain the determinant of matrix A, and also I will obtain the A adjoint. After that, I will make just multiplication. Hence, we have the matrix A. Let's first try to compute the determinant of A. To do that, this matrix, as you can see, just 3 by 3 matrix. Then to find the determinant, I will make big bracket multiplied by small bracket, minus big bracket multiplied by small bracket, plus big bracket multiplied by small bracket. If you remember, inside the small brackets, I will put the first row here. Then I will put what and what and what. I will put 1 and then 2 and then I will put again 2. And inside the big brackets, I'm going to put negative. Then here it is. And let's start. As we used to do, to fill the first bracket, I will go to the number 1. Here it is. And I will try to hide the row and the column. And let's now make cross multiplication. Negative 2 multiplied by negative 1, just positive 2, and 1 multiplied by 1, which it will become only 1. By the same way, to fill the second bracket, I should go to the number 2. Here too, I will remove the row and I will hide the column. And let's start. 3 multiplied by negative 1, it will become here negative 3. And 1 multiplied by 2, which it will become how much? It will become 2. And then to complete the last bracket here, I should go to the last 2, and I will try also to hide the row and the column and start to make multiplication. 3 multiplied by 1, which is 3. And negative 2 multiplied by 2, it will become negative 4. But here I have negative, regard that it will become plus 4. Now just try to simplify with me. Then determinant A equal to 2 minus 1, just 2 multiplied by 1. Minus, here I have negative 3 and negative 2, which is negative 5. Multiplied by 2, and I have 3 plus 4, which is 7 multiplied by 2. Then you can simplify again. Then determinant A equals to 2 multiplied by 1, just 2, and here I have negative, which will become positive, and 5 multiplied by 2, which is 10, and finally I have 7 multiplied by 2, which is 14. Now you can add all of them together. Then here I have 2 plus 10, which is 12, 12 plus 14, it will become 26. Then I have now with me determinant A. Then determinant A with us remain for me what? To complete the answer, the adjoint. Then here I am going to compute the A adjoint. In the case of 3 by 3 matrix, how to obtain the adjoint of the matrix? Yes, throw 3 matrices. Then this is the first one and the second one, and the last one, it will be the adjoint. Then to compute the A adjoint, first of all, I will compute the minor of each number. Then the minor of 1, what? I will go to that one and I will remove the row and the column. And let's start. Negative 2 multiplied by negative 1, which is 2, positive, minus. Here I have 1 multiplied by 1, which is 1. 2 minus 1 is just 1. Then here at the place of 1, I will put 1. By the same way, I will compute the minor of 2. Then I will remove the row and the column. Let's start. 3 multiplied by negative 1, which is negative 3. And here I have 1 multiplied by 2, which is negative 2. Then the answer will become negative 5. Then here I will put negative 5. Then again, now to compute the minor of number 2, here I will remove the row and the column. And let's start. 3 multiplied by 1, just 3, minus negative 2 multiplied by 2, which will become negative 4, here plus 4, then the addition will be 7. That's mean I will put here 7. Then now we have finished the first row. Now let's take the first number in the second row, 3. I will remove the column and the row, and let's start. 2 multiplied by negative 1, negative 2, minus, here I have 2 multiplied by 1, which is 2, then the answer will be negative 4. Then at that place I will put negative 4. Now let's compute the minor of the number negative 2. Remove the column and the row. Let's start 1 multiplied by negative 1, which is negative 1. And here I have 2 multiplied by 2, which is negative 4. The answer will become negative 5. That's mean here I will put at that location negative 5. By the same way, let's compute the minor of the number 1. Then I will remove the row with the column. Let's start 1 multiplied by 1, which is 1, minus 2 multiplied by 2, which is 4. Then the answer will become negative 3. Then the minor here, negative 3. Now let's compute the minor of this number, which is 2. Then remove the row and the column, and let's start 2 multiplied by 1, 2, minus 2 multiplied by negative 2, which is negative 4. Here will become plus 4. Then the answer will be 6. Then the first minor here, just 6. Now we will compute the minor of number 1. Remove the row and the column. Then 1 multiplied by 1, which is 1, and 2 multiplied by 3, which is 6. Then the subtraction will be negative 5. Then here I will put negative 5. The last minor here with us, which is negative 1, remove the row and the column. Then 1 multiplied by negative 2, negative 2, and here I have 2 multiplied by 3, 6. Then the answer will become negative 8. Then I will put here negative 8. Then the matrix of the minors finished. Now let's compute the cofactor. Then now I will change the sign of those numbers, this one and this one and this one and this one, and I will keep the remain. Then it will become what? 1 and positive 5 and then 7, and then positive 4 and negative 5 and then positive 3, and then 6 and then positive 5 and then negative 8. And this is called what? The cofactor matrix. Now I will find the transpose. I will take the first row and I will make it their column. Then 1, 5, 7. The second one, which is 4, negative 5 and then 3. The third one, which it will become 6 and then 5 and then negative 8. And this is the adjoint, which I will substitute about it here. Then now to complete the answer, the variables x and y and z equals 1 by the determinant. The determinant we did it before, which it was 1 by 26. The adjoint, which we have finished just right now, then I will copy it just here. And now the matrix of the three numbers, I will put it, which is 5, negative 6, and then negative 7, and negative 1. Now let's try to make the multiplication row multiplied by column. It will give us just row. Let's start. 1 multiplied by 5, which is 5. 4 multiplied by negative 6, which is negative 24. And the third number, 6 multiplied by negative 1, which is negative 6. Now we have finished the first row. Then I will deal now with the second row. Then let's now try to multiply the second row by the column. Then 5 multiplied by 5, which is 25. And negative 5 multiplied by negative 6, which is positive 30. And 5 multiplied by negative 1, which is negative 5. Then now the second row finished as well. I can now remove it. And let's now deal with the last row. Then I will multiply the last row by the column. Let's start to make the multiplication. Then 7 multiplied by 5, which is 35. And here I have 3 multiplied by negative 6, which is negative 18. And then negative 8 multiplied by negative 1, which will become plus 8. Now let's simplify. I have here 5 minus 24 minus 6, which it will become negative 25. And 25 plus 30 minus 5, which it will become just 50. And 35 minus 18 plus 8, which it will become 25. Then now I will multiply this number inside in each one of those. Then it will become here negative 25 divided by 26, and 50 divided by 26, and then 25 itself divided by 26. Then the first number x equal to the first value, this value. Then here x equals to negative 25 by 26. And the second number y equal to the second value. Then y equal to 50 by 26. and the third value, which is z equal to the third value, then z equal to 25 pi 26. Then here I have the solution. Now by the same way, try to use the inverse coefficient matrix to solve those two cases. For the first case, try to find x equal what and y equal what, and for the second case, try to find x equal what and y equal what and z equal what.